We are going to look at how to determine the key points of a parabola from a table or from a graph. In this example, you can see that we have a table. We're going to start by trying to figure out the x-intercepts. This table has two x-intercepts. What we need to do is look to see if we can find where there's a value for x but a 0 for y. We've got two of them right here. The first one is negative 6, 0, and the second one is positive 4, 0. The next thing that we need to do is see if we can determine what the y-intercept is. For the y-intercept, we're going to try to find where there's a 0 for the x value, but then a specific value for y. So in this example, the y-intercept is 0, negative 24. The last key point that we need to figure out is the vertex. Parabolas always have symmetry to them, which means that we should be able to find some points in the table that match up. If you look at this table, negative 7, 11 is going to match with 5, 11. Our x-intercepts will match. Negative 5, negative 9 is going to match with 3, negative 9. And if we keep working our way to the middle, we can see that our vertex is at negative 1, negative 25. Another key thing to remember about the vertex is that the vertex is always going to be the highest or the lowest point on a parabola. In this example, it's going to be the lowest point. So the very bottom of the parabola would be at negative 1, negative 25. The next thing that we should do is figure out where the line of symmetry is. Once you know the vertex, the line of symmetry should be pretty simple to figure out. Parabolas are always symmetrical right down the middle, which means that the line of symmetry goes through that vertex. All we need to do is look at the x value for our vertex, and we've got our equation for our line of symmetry. For this problem, it's x equals negative 1. The next thing that we're going to do is see if we can figure out what the equations are going to be in both factored form and in graphing form. In order to figure out the equation in factored form, we're going to go back to those x-intercepts that we figured out first. Since there's two x-intercepts, our equation is going to have two sets of parentheses, or two factors. Both of these are going to start with just x, and then all we need to do is look at our x-intercepts and think about what the opposite of them would be. If our x-intercept is at negative 6, that means that our first factor is going to be x plus 6. If our other factor is at positive 4, that means our other factor is going to be x minus 4. The last thing for us to do is to figure out what the equation would be in graphing form. The key thing to figure out the equation in graphing form is to look at that vertex again. We're going to start with a parentheses, and just like we did in the factored form, we're going to flip or think about what the opposite of our vertex would be. So instead of it being a negative 1, we're going to switch it to be x plus 1. Graphing form always has a square right after the parentheses. And then the last thing to do is to look at the rest of the vertex. Since this vertex is at negative 1, negative 25, we're going to keep that negative 25. The negative 25 isn't in parentheses, so we don't have to worry about changing it or flipping it.